Hello everybody, today we're going to be discussing about chemical nomenclature. Nomen meaning name, clature meaning systems, together it's a system of naming. So we're going to discuss these types of compounds that we are going to name. Ionic, which is non-metal and metal. Covalent, both non-metals. And types of covalent are organic, hydrogen and carbon, acids, hydrogen and another non-metal. Anything other than that is just regular covalent. Start with ionic. So the rules for ionic nomenclature. The cation goes before the ion. A simple cation retains its name, so the cation doesn't change its name if it's a simple cation. The monatomic anion has the suffix IDE. And polyatomic anions have endings of 8 and ITE and should not be changed. So let's see, for instance, sodium chloride. Sodium is Na, chlorine is Cl. Now look, this Cl, chlorine, there's only one of them. Actually one of them doesn't matter, but there's only one type of atom in this compound, which is chlorine. And then there's a sodium that's going to be bonded to it. So this chlorine will be called chloride because it's a simple monoatomic anion. So chloride. And the sodium retains its name, so the compound's name is sodium chloride. Let's talk about complex ionic compounds. So some elements have multiple cations, which are the transition elements. So first to calculate this, find the anion's charge. It tells you the charge the cation needs to have to cancel. So for instance, this compound right over here, sulfur is an anion. According to the periodic table, it has a charge of -2. So that means that this other copper, this Cu2, needs to have a charge of 2+. So this whole thing, Cu2, all this have a charge of 2+, to cancel out with the sulfur. We just calculate the cation's charge. So if this is 2, and this needs to be +2, then how many coppers are there? And what is the charge of a single copper? Correct? It's 1 plus 1. +1. So each of these coppers has a charge of +1. Two of them has a charge of +2, which cancels out the -2 of the sulfur. And to make this clear, we put the charge of the individual copper right after the name of the cation. So it's copper, Roman numeral 1, sulfide. Now let's talk about simple covalent. This is legit the easiest thing. So there are prefixes for both of the elements, and we just simply put these prefixes in front of it. So if it's like one of this element, one of that element, you just do mono. You just do mono with the second element because the first element does not need a prefix if it's only mono. Let me show you what I'm saying. So H2O, hydrogen, oxygen. The prefix for the hydrogen will be di, since there's 2H2. So dihydrogen. And the prefix of the oxygen will be 1, because there is 1 oxygen. So it's dihydrogen monoxide. Notice the "ide" because this is a monoatomic. Okay. Now organic. Organic's the hardest, but it's not really that hard, guys. So organic here, the prefix is dependent on the number of carbons. So these are all the prefixes. So the number of carbons. So if you have 1 carbon, the prefix is meth, 2 eth, 3 prop, 4 bute, and etc. etc. The suffix is dependent on the bonds. So if it's a single bond, it will end in ane. And that means, you easily check this in the formula, the number of hydrogens is 2 more than double carbons. So if you have 1 carbon, double that is 2. And then plus 2 more is hydrogen, that's a single bond. And double bonds, that means the number of hydrogens is double the number of carbons. So if you have 1 carbon, that would mean 2 hydrogens. And triple bonds ends in yne, which means that the number of hydrogens is 2 less than double carbons. So 1 carbon, multiply that by 2. Actually, that wouldn't work. But anyways, if you have 2 carbons and you multiply that by 2, that's 4. 2 less is 2 hydrogens only. Let me show you what I'm talking about. So organic here, CH4. 4 hydrogens, 1 carbon. So 1 carbon means a prefix will be meth. And the number of hydrogens is double the number of carbons plus 2. You see, So this is right here, A. And you know how I can see this? Because there's 4. Pretend there's an invisible one here, okay? 4. Okay, you double this 1 first. And it's 2 less than this 4. So that means the number of hydrogens is double the number of carbons plus 2, which means it ends in ane. So the full compound name is methane. Finally, let us discuss acids. Acids we just went over recently. And there are only like simple rules to acids. So if the anion just ends with "ide," meaning it's monoatomic, remember that monoatomic "ide." If it ends in "ide," it would be hydro, name of the anion, ic acid. If the anion ends in "ate" or "ite," and with these two are polyatomic. If it's an "ate," it becomes blank ic acid. If it's an "ite," blank us acid. So let's take HCl, hydrogen and chlorine. The chlorine anion is monoatomic ide. So it will be hydro blank acid. You would put the chlorine in this blank right here. So it's hydrochloric acid. That was very simple. Thank you for watching, guys. Good luck for the test. And remember to thank me.